Interesting. Okay, new challenge. Writing a simple function. The challenge is as follows. We have as input the value, or well, let's call it the range, but well, it's just two values, min and max. So given the range min max inclusive, or maybe I don't want to do it inclusive. Now I think about it. No, it is inclusive. Those values are floating point, so they can be negative, or minus 0.3 or plus 105.6. Anything goes. However, let's call this the range R. Now we have the value S, which is, I'm going to do it. Let S be the set 1, 2, and 5. Let S be in S. So lowercase s is 1, 2, or 5. Let d be s times 10 to the power n, where n is an integer. So n can be negative here as well. Now, for the sake of testing, I think we can safely only test for n running from -6 to +6. Yeah, which is what I did here. So this is 1 millionth till, well, actually just 100,000, but then times 10 is plus a million. So now S and N together form an infinitely large set, or a finite set if you let run N only run from -6 to 6, in which case we have 13 possible values for N, times 3 is 39 possible values of D. And for each value of D, you can determine the values K1 and K2 such that K1 times D is greater or equal min. So let's K1 be the smallest integer such that, and then let K2 be the largest possible integer such that K2 times D is less than or equal max. then the total number of k values in that give that multiplied by d fall inside this range is equal to k2 minus k1 plus 1. We call that m. Now the challenge is to find an S and an N, aka a D, from the set that it is that the values can be. Such that M is as large as possible, but not larger than 10, unless the next smaller value of M is less than 5. Hey, Koto. Koto. So what is the smallest d? The smaller d, the larger m, because if d is very small, then there are more k values. Yeah. So m and d are if m becomes larger, if d becomes larger, then m becomes smaller, and if d becomes smaller, then m becomes larger. So we want to have the largest m, largest possible m, so we are searching for the smallest d, such that m is less than or equal to 10. But m is greater or equal to 5. And if that is not possible, then the largest d, such that m is greater or equal to 5, you can always make d larger and larger, and then m becomes smaller and smaller. M can even become 0, then there is no... wait a minute, I'm adding 1 here. I mean, there can be no k values at all for which k times d falls in this range. S and d are not related at all. S is just 1, 2, or 5. And R is in a floating point range. Things will become more clear if I just write test code, I think. Trying very hard to get at least a formulation that is correct. What is this? So we're setting for the smallest d, which makes m larger and larger, such that m is still less than 10 or equal. I'll make an example, okay. But m must at all times be greater or equal to 5, so we cannot go too large with d. Wait a minute. This last sentence is still a problem. Yeah, to rather this. What is the smallest d such that m is less than 10? I think I should just stop there. If so, if for that d m is less than 5, then, well, then just take the next largest d. I'll make an example. Sorry, let me get this one right. What is the smallest d such that m less than 10? Yeah. If for that d don't you hate it? It's just a space here. Okay, I think I got this right. Well, we will see now. Okay, I need test cases, right? So the only input here is min and max. That's the only input. But then the only output is d. However, then once we have a d, we can test if it fulfills these conditions. And there is only one d that's correct. And we'll definitely need a test suite for this, because it's just hard to wrap our head around. So I think I need a test suite where we run over many values of min and max, and then test that, you know, so just lots of different input values. And I think that okay, now I can need your input, Kotaro. What is the how to generate min and max? What I did here is I have from small to large, and then I multiply that with this, and then I get one value that is nice to test with. But that would be for the difference. This is a good way to test the difference, max minus min. So we would have to at least generate one of them first, and then we can add this. You want examples? Well, okay. I can do one manually, so give me a min and a max value then. So, for example, if min is, give me a value. I don't care what it is. Yes, no. Are you there? Koto? Okay. Minus 10.1234. Oops. 1234. And max is must be larger than min. Yeah, no max. Is there so much delay here? Or Jesus Christ, what a lag. Can you not... that's the same value. That's the min value. Can you not go to the YouTube window and scroll forward? If I watch myself, then often I can be many minutes behind, and I just take the slide bar and yank it to the right, and then I'm at the end. Oh, you meant it like that. Okay, well, I have inputs now. Well, in that case, for example, D could be 10, right? I mean, that's allowed. That is 1 times 10 to the power 1. 1 times 10 to the power 1. It's an allowed value. However, if D is 10, then our K values are K1 is minus 1. Because minus 1 times 10 is equal to minus 10. That is allowed. And it is equal to minus 10. Yeah? Min is minus 10. D is 10, so K is minus 1. And K2 is... well, max here is 9,999. And D is 10, so K is 999. Yeah, that's not good. The stream is buffering. I don't know how to change that. I can reduce the bandwidth a lot. But my upload bandwidth is enough. Okay, can K2 be larger than this number? Let's check it. So 999 times 10, right? This is our guess. That gives 9,990, which indeed is less than or equal the maximum value, which is 9,999. But if we would pick k2 one larger, that is 1000, then we get 1000 times 10 is 10,000, and 10,000 is no longer less than or equal 9,999. Therefore, k2 is this value. That is the largest possible integer, namely such that 999 times 10 is still less than or equal 9,999. Therefore, k1 is this and k2 is that, which then means that m equals was given by this. So that is 999 minus 1, this is 1000, plus 1 is 1001. And we need to find a d such that m is less than or equal 10. So not the right value. Let's try another value. Let's try 1000. Now in this case we have, I think, the smallest value, the smallest possible integer k, such that this is larger than min, min being minus 10, is 0. 0 is larger than minus 10, and then the one below that is going to be minus 1000, which is not larger than minus 10. So now k1 is 0, and k2 is now 9, I think, because 9 times 1000 is 9000, which is less than this. While if I would have picked 10, you get again 10,000, which is again larger than that. So now you have the new, for this d value, we have k1 is 0 and k2 is 9. And therefore m is 10. 9 minus 0 plus 1. And that is correct. The question now, is this the smallest possible d? Because it does fulfill this, but maybe you can even pick a smaller d. Well, the next smaller d would be d is 500, yeah, because it must be 1, 2, or 5 times the power of 10. So this is 1 times 10 to the power 3. So the next smallest d that is allowed is 5 times 10 to the power 2. But obviously, if you take 500, then well, k1 is still 0 and k2 is going to be like 18 or 19, probably 19. So then m is larger than 10. Yeah, I mean, if you make d smaller, then m becomes larger, and it was already 10. So this is indeed the smallest possible d such that this holds. Plus, it is the m value that we found, which is less than or equal 10, could be less than 5, but it's not. So we're done, and this is the d value that belongs to your input. But this input you should find d equals 1000. Do you now understand what it means? But you're going to need a lot of testing inputs. I think we should split the test up in generating a min value and then generating the max value by adding a range, and I want to use these values. That is this times that for the range. And then let's use for the min value plus and minus the same values divided by 10. I'm just doing something. That will definitely do all the tests that are necessary. It will probably do 1000 times more tests than necessary. But if you don't have to look at the debug output for all of them, then that doesn't matter. You can easily test 1,000,000 test cases. So doing so, we can do... Let's make a vector with all the possible min values. Yeah, so we are just, I have this as a vector and we have this as the power. It's just a name. But the multiplication between them gives me all interesting values. And yeah, this is nonsense. I have to do a pushback of all those values. And then we run again over this. Do it differently. Like say double min. No, actually, let's not do that differently. Sorry. Okay, so this is then, let's say, max minus min values, test values. And I said I wanted to use for that the same values divided by 10. And then we can loop over both. So we have a min, runs over all possible min values. And we have a max, which runs over all possible. No, we don't have a max. We have a max minus min value, which runs over all max minus min values. And then we have a max, which is then min plus max minus min. And now we print out our range. And I made a shitload of errors. No, I just didn't include vector header. So these are all the test ranges that we'll be using, and that's just a very big number. Well, only 11,000 tests. Now, you can write a function that gives me the delta, but that we need to test at the very least if it is correct. So given a delta now, given a d value, we must be able to test if that is the correct d. let's make a class for D and then store it as two integers. I'm going to store it as S and N. So I make a class D. I'll make it a struct. Everything public or not. It exists of S and N. It can be converted to a double if you want to. Some automatic conversion. You can assign it to a double, pass it to a function that takes a double. And the actual value is S times standard power of 10, n. Yep. So that, and then S of course must be a 1, 2 or 5. Maybe I should make it private, so I can enforce that a little bit easier. Let's see, so I can make a default constructor, say, which fills in the values that are that belong to the smallest possible value, and then we make an increment to run over all other values. So the smallest possible value then is obviously S equals 1. And n equals minus infinity, but we are just started at minus 6, that should be enough. Although, now I think about it, maybe not, because we have already very small numbers here. Okay, let's go to 8. It's gonna use a lot of CPU, but hey, as long as we are sure that it works. Yeah. Now we can test this little thing. Don't need this at the moment. Don't need that for this test. So just construct a D, and then while D is less than so these are then all allowed values of delta, starting at 10 to the power minus 8, and then we have 2, 5, and then we go to 10 to the power minus 7, 2, 5, 6, 2, 5, 5, 2, 5, and this is then 10 to the power minus 4 times 2 times 5, and then the same 3, 10 times larger, 10 times larger, 10 times larger, 10 times larger, and so on 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 until we reach 10 to the power 8, which is not included or not printed. Now those are in fact pretty limited. I think we can just brute force this now. So we could do the following. We run over all possible ranges. And then for each range, I'm going to run over all possible D values. And then we have to figure out if this D value is the correct one for that range. Now, how do we do that? The point being that actually we want to find the smallest D such that M is less than or equal to 10. Okay, well, we start with the smallest D. So I think I just calculate M and then we check if this is the case, and as long as it is not the case, we go to the next D value. Yes? So this must be a loop that runs over all values of D where we calculate M. Let's do a calculation. Do M is calculate M for min and max. While M is larger than 10. You start with a very small d, therefore we get a very large M. And if that's larger than 10, and that should be the first time, then we run again. So maybe I should do the calculate up front here immediately. And just assert that this M definitely violates the initial condition. And then I do the loop, which we then always do the first time. And then we calculate the M again. That is also a function of d. And now I put d at the end. Okay, d at the end. Well, since we know that the initial one fails, we can begin with incrementing d. Calculate it again, and then if it still fails, increment it again, and so on. And then as soon as m is less than or equal 10, then we do not do this anymore, and then we found the smallest possible d such that m is less than or equal 10. Yes? However, if this results in an m that is less than 5, then in fact we should have used the d that is smaller, one smaller. So I just do a minus d in that case, which I'll then have to add. Maybe I should move my initial comments into the code. Let's first get it a little bit closer. So given a range R, the range runs from min to max, and we print it here. This belongs more in the class. No, let's not do this. It just complicates stuff. I'll just make a copy of the I think, which is then the previous pre-incremented value. So I have a previous d, and then before incrementing it, I assign it. And this, if this is true, then d must be set to the previous d. And now let's recalculate m as well then. Or I could add a previous m as well, but well. Does this look correct? I say here the next largest d, but now I'm decrementing it again. So making d smaller makes m larger, so this makes sense. I think I'm gonna delete the example. Hello, Spectre. Yeah, I don't know if I can describe it any better than already have described it in the description. Did you read the description of the video? And it's in the comments now. So you have a double a floating point value that is s times 10 to the power n, where both s and n are integers, and s is even an element of the set 1, 2, or 5. And then the question is, what is the smallest d such that m is less than or equal to 10? Where m is given as this, where k2 and k1 are given as that, and I still have to implement this, and everything I wrote now is brute force. Let's see. To have a reference, I can write my real functions and compare them to the brute force values, and then they should be equal, obviously. Okay, well, clearly return this as per definition, and then k1 is the smallest possible integer such that greater or equal min well, that's something very close to min divided by d. I guess the ceiling of this. I suppose the correct value of the without the ceiling we get 3.5. That means that 3.5 times d equals min. Then in order to make it larger or equal, with k1 being an integer, we need to make k1 larger. So take the ceiling of 3.5, we get 4. That would be correct. And if k1 is already an integer, so the ceiling doesn't do anything, then this is just equal for whatever k1 is already. And then, yeah, k1 should be exactly that, min divided by d. So this is the correct formula, right? And then the other one, k2, well, this goes the other way, so this is probably the floor of max divided by d. Because if this would be, if equal sign requires a floating point value, then we have to round down k2. And if it is exactly equal, then we don't want to do anything, which is totally correct. Let's see how long this takes. I just run it. Pretty fast. But it goes wrong for this range. Assertion m equals m is larger than 10 fails. And I can't type. Or I forgot a semicolon at least. I don't get this because this is 100 times smaller than these values. Oh, that is 1.1 to 1.2. Yeah, that difference is 10 to the power minus 7. So then in with this, you get already in 10 steps from here to there. So you need to make d even smaller. I think the smallest, the smallest difference I make here is a tenth of that thing here. Oh, here's even even smaller thing. Not necessary. I don't want to do this one. Although it's still super fast, I just don't think that is necessary. So 10 to the power minus 9 should be sufficient then, to begin with. Wow. A ministry and maxistry. Oh, why? Yeah, well, that's M is 1. Yeah. I still have empty ranges. That would that's even worse. Why would I get an empty range? Because max minus min is 0, which is pushed back here. I think it's because factor is 0 at some point. No, it's not. I don't have any 0 in it. The question is, what is the smallest max minus min value that I put in here? Oh, it is another 0.1 here. I think I just the precision is not large enough. So yeah, it's not 3 and 3, it's 3 and 1, 2, 3, 1, 2, 3, so 10 to the power minus 7, which is, I mean, there's a 1 here. So the still a bit confused now. Huh? Is that not set position? Yeah, just like that, and maybe because it is sticky, it doesn't have its own thing. Hmm. So yeah, it's 10 to the power minus 7. I would say if we make steps of 10 to the power minus 9, that's 100 steps, not one step. Dung, 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 dung. Oh, we must be doing something really wrong. Yeah, totally wrong. Utterly PS wrong. Well, no, wait a minute. I think we just have a floating point position problem here. Or int is too small. Yeah, that's better. So that just finishes. Well, does this now mean that that this works? As in, we found the correct D for each and every. Looks good. So M is always 5 or larger, and sometimes it's 11. So find the cases where M is 11. It's quite a lot. Sometimes it's 12. Wow, it's never 12. You gotta be kidding me. Well, I thought that it is possible to get 12. It should not be possible to get 13, but 12 should be possible. which makes me think then maybe the test suite is still not sufficient. Doesn't test every case. We should get 12 if for example, if we have let's say if D is 2, no, if D is 5, we should get M is 4. For example, you could visit the values 10, 15, 20, 25, which is not enough. And that also means that we do not get 5, so 5 falls outside of the range and 30 falls outside of the range. And then with D is 2, I want to get 12 values. Well, to squeeze in as many as possible, while 5 is still outside the range, I'm going to start with 6. 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and then 30 again outside the range. How many is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Ta-da! Yeah. Hence, min is 6 and max is 28 should do it, or 28 or 29. Apparently we're not testing that. Bad test. And I was thinking I was testing a lot. So I want to get 628. That means the difference must be 22. And that is 1/10 of it. So we must 220 must be in the range and 6. Well, we have 6. And we do not have 220. So I do like that. Now we have 220. Imagine having tried to guess that with trial and error instead of thinking about it. What the hell? I've got to add a comma. 6 to no. Oh. 2. 16. Yeah. Feels good to be right. And this should include the case of 6 to 28. because that's what I was aiming for. Well, we have 62, 280, that's equivalent. But damn, I don't see 6 to 8. 6 to 28. How is that possible? That's really weird, man. I have 3 plus 220. This is 6. Wait a minute. This is plus 220. No, I want to have plus 22. Oh, I don't have 100 in here. Right. No, wait a minute. Yeah, I need 100 to get the value that I wanted. Well, it still worked, but at least that explains why the exact value that I went after isn't in there. There it is. So I was going for this one. The range 6 to 28, D is 2, and then M is 12. Because if you use D is 5, then you only get 4 values. So yeah, it totally works. Cool. Now we want to write a smart function, not stupid brute force stuff. So let's put this brute force stuff in a function, which then returns the D value given the min and max. Yeah, I don't have M anymore here. I would like to have M as well, just to test. Yeah, let's just write it. Okay. So there is no 13. That's, yeah, okay. And obviously there is also no MS4 or smaller. And this is 10, 11 or 12. And then I go back to my coordinate transformation program, for which I need this. Don't have an almost equal. It's not even in the directory. Yeah. Let's just steal almost equal from utils. So that is defined in, for example, don't need a complex version. Just this. Okay, the smart version. Yeah, now it really begins. This is now it starts interesting because it's no longer brute force. So I think that yeah. It is as usual mind-boggling difficult basically, or I'm just too stupid. More likely, yeah. But probably a good approach would be to get a reasonable estimate first. How about we find? Let me think. So what we have is we have an axis, and then we have the min value. Yep. And then we have a max value. And then we have values that you can get by multiplying delta with some integer. And these values are, for example, here, and then there is a distance, which is then so k times delta, so now k becomes 1 larger, so this distance is then delta. And that then repeats. Yeah. But you don't know exactly where it is because, well, it depends on delta and rounding off the fraction of the min and max relative to delta. So it could be like this or like this or like this. And as you can see, now we have more values in the range, namely 1, 2, 3, 4. And if we do this, then we have only 3. Both are not allowed. We must have at least 5. So let's make this thing a little bit larger. Let's say if the shift was like this. Let me add one more then, to at least continue outside the range. So now we have in total 1, 2, 3, 4 values inside range, which is not enough, but it could be that it is like this, and then they are both exactly on top of the... I'll just make it even 1 larger. So like this and or like this, we would have 5 in the range. But that depends on the values of min and max itself, yes, and the value of delta. So how much variation can there exist? Is my first question. So just plus or minus 1, or just plus 0 or plus 1, or? I guess so, yes, because if the first value is exactly on min, then you have the maximum number possible values in it for a given delta. And then only if you shift it a little bit until this one falls out, and the next one doesn't come in yet, so I should really I think not enough space for that. I should put this thing there really. Or not. So now we have 5 in it, and now we have 5 in it, and now we have 4 in it. And still 4, 4, 4, 4, 4, 4, 4. It's a lot more 4s in this case. But I think we can make an estimate, right? Because we know that this count is going to be 5, 6, 7, 8, 9, 10, 11, or 12. Other values are not possible. Say if the number of, and I described it as k, yeah, I think k. So, you know, I spread out my comments all over the program and I can't find them back anymore. The description. Oh no, oh no, here's a k, okay. It's k times d, yeah. So if the number of values of k sorry, but I think k1, so this value here belongs to k1. This one. K1 is the smallest integer such that K1 times delta is in the range or on top of min. And the same holds for K2. So in this case, this would be K2. But we also have the possibility that, I mean, well, we just don't know really. At the moment, before we know delta, we don't know it. That's basically the point, so it's a bit unclear. It could be that they are exactly on, that K1 is exactly on min. And yeah, then K1 is here, K2 is here, the next one. It's just, it still falls inside that range. And I think that being exactly equal might be a special case. So let's visualize that for all possibilities. There is also a possibility that K2 is exactly equal to max and K1 is not, and then we have the possibility that both are exactly equal. But yeah, in that case I need to make the range a little bit smaller. I can't change my delta. Now I'm writing K1 and K2. Maybe I should do K1 times D, because that's the actual value, of course. Just 2 more characters. D is equal to delta. And so K1 equals min. Is less than max. Let's go for that instead of this English description. Yeah, so these are cases that might need to be distinguished. Here I'm talking about M really. So the number of values of K. I defined M to be K2 minus K1 plus 1. So this would be 1, 2, 3 plus 1 is the number of carrots that fall inside the range. Let's call this inside the range. So here we can say M is 1, 2, 3, 4. That's a number of carrots that fall inside the range. And then here M is 5, and here M is 5. And here M is also 5. No, 1, 2, 3, 4, 5. Yeah. Well, that's rather arbitrary. Just I picked these numbers by chance for those special cases. But of course, we can have an example where this holds, where M is whatever, 5, 6, 7, 3, anything. But in this particular case, you see that there is exactly 4 values inside the range. Um, okay, before I was thinking about this, I defined a variable called rs, which is the range size. You define that as max minus min. And then a logical thing to calculate is RS divided by 10, because that would be the case if they are not equal, at least if unless it is this case, and that is very unlikely. I mean, yeah, then both have to be exactly that, and it's more or less fuzzy, so it's more likely that they're not exactly on top of it. That this is one larger than that doesn't matter. I mean, that's coincidence. I mean, I could also let K2 just fall outside here, and then it would be 4, right? I mean, what does hold, however, is that if the delta could be equal to RS divided by 10, then I think we have this is just the a delta, and that is pretty damn close to the final delta. It's not a factor of 10 off. It's not a factor of 100 off. I think it's a maximum factor of 2 off, actually. But in which way? So yeah, maybe I should just run the test suit again and then brute force the range in which this falls. I think that's a good plan. So we can't do this yet. So I just brute force the correct value of D, and we calculate. Well, I'm gonna set the size here, which is obviously equal to, well, that is the size. I'm going to calculate how should we call that? I think it's kind of the ideal D. The ideal D would be RS divided by 10. Why? Because we want to make D as large as possible. No, the other way around. D as small as possible, such that M is still less than or equal to 10. And that means that we want M to be as large as possible. But it cannot be larger than 10. So the ideal value of M is 10. And therefore, if you just fill in 10, we get the ideal value of D. However, this is not even necessarily an integer, let alone 1, 2, or 5 times the power of 10. But we are close, I think. So the question now is then, what is the factor that we are off? So let's say, well, I'm calling it off. The factor that we are off is, say, ideal D divided by, or the other way around, brute force D. And then I want to find the range in which off lives. So if off is less than off min, we set off min to off, and if off is larger than off max, we set off max to off. Shut up. I don't recognize these numbers. I would say 1.2, it makes more sense. And the 0.4, can't make anything of that. But yeah, we're not testing everything. They'll probably get a better approximation if I just try a million random values. Because these are not random. Maybe not random enough for this. So instead of looping over these values, I should run over random values. $10 million. Maybe not enough. 100 million random values. Random device. Now we use the Marchant twister, obviously. Nonsensical. Let's say minus 100 to 100. Oh, you guys can't see what I type. Excusez-moi. Okay, 100,000 is 100 million is more than I thought. Can't take that long, can it? Oh, actually, it can take very long because brute forcing stuff is also already in a horrible, horrible loop. Let's begin with, I don't know, a lot less. 1 million should be possible. Okay, well, definitely looks like 0.4 and 1.25. Right. This is 1 divided by 2.5, which I bet comes from the factor between 5 and 2. And 1.25 I don't know, 1.25. The thing is that in the end we are going to get D equals yeah, so RS divided by 10 is I call the ideal D here. Call it here as well, ideal D. Where we just cut up this range in exactly 10 pieces. But then we need to do a round of the delta to a nice value, and it can indeed go either way. If you say, well, it's definitely not allowed to have more than 10. M can be at most 10. Then the real delta that we're going to end up with is going to be larger than the ideal D. Let's call this, I had that function already written, I think, so we can do, let's call it the nice ideal D is, I was discussing this with ChatGPT, I think. ChatGPT, I didn't use ChatGPT, but I was using it as a rubber duck. See if we can find that back. Blip. Oh, we're still typing. Yeah, this function here, nice delta. Well, that niceifies the delta, as in makes it an it makes it 1, 2, or 5 times the power of 10 by running it up, I think. Yeah, there's a ceiling in here, so. There you go. We need to round the delta up to the nearest 1 to 5 times power of 10. A power of 10. So that means that we might have to multiply it with up to 2.5. Yeah, so it could be either exactly the ideal value, but it's also possible that we had to multiply it with 2.5 times ideal D. Because if, say, the ideal D is exactly 1, 2, or 5 times power of 10, then there no rounding happens, and then this equal sign happens. And if it is not equal, then then this is larger. We round it up, so that's larger than. But we can never have to round it up more than a factor of 2.5, because let's say it was, the ideal one is 2.00001 times power of 10, then we have to go to 5 times power of 10. You cannot go down to 2 times power of 10, because you can only go up. So if 2.001, we have to go up. And we have to go from a little bit more than 2 to 5, which is a little bit less than 2.5 factor. Hence the less than. And then after doing that, we can calculate M. And now the maximum M that we can get is by dividing RS by the ideal nice D. So we have the maximum M that we can get is the range size divided by the nice ideal D. Which you would get if you just think that we start counting admin and then just count the number of deltas that fit in it. It's the maximum number that you could fit into it. But because min and max itself might not play nice with whole values of delta, it is possible that that both of them are somewhere in the middle of that range, and then we could have one m less, as is shown in this case actually, that well, the relatively seen, these are relevant. Because if this one lines up, then we do get 5, and then if we shift it until K2 lines up, then we still have 5, per definition. But if we shift it even further, then we would get 1 less. Yeah. And this is a whole different case because I had to shift max a little bit to that side. That's kind of cheating. So I would say, yeah, m then is less than or equal m. Sorry, m is max m minus 1 is less than or equal m, is less than or equal max m. So m is just equal max m, it could be 1 less. Ish. And now the question is, what are the possible outer values of m, and then how we have to correct it, right? So can combine this one and this one. If this equal sign holds, then max m equals or s divided by ideal d. And if nice ideal d is larger than ideal d, then this becomes less. So, in fact, max m is less than or equal. Max m is equal if this is equal to that, but this could be larger than that, therefore you divide by more, and therefore this becomes less, so then it would be less than that. While if this factor of 2.5 almost holds, let's say it holds, so let's say if this is equal to that, then we can just replace this with that, and then we get max m is rs divided by this. Let me write it out. So then max that equals divided by this. That is a limit. And I want to express it as in the ideal D, I think, yeah. So the limit is Rs divided by ideal D, all divided by 2.5. Like that. Because it can't really be equal because of this unequal sign. So the max m is going to be squeezed between this value and the same value divided by 2.5. Where Rs divided by the ideal D is 10 because of how ideal D was defined. So this is just 10. So this then means that this is 10 divided by 2.5 is 4, is less than max m is less than or equal 10. Which in turn means that 3 max m is larger than 4, and if max m must be is an integer, so it's it could be 5, but not less than that. Cannot be 4. Can this not be equal? No, it cannot be equal. Although it could be very, 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 very close to equal. So, yeah, but still. Anyway, subtract 1 from that. It seems to me that then definitely can be equal. So m lays between 4 and 10. Which is exactly what we want, unless m is less than 5, which is possible, because it could be all the way down to L4. So apparently, if m is less than 5, we are going to do something else than use this nice ideal D. And it should only be possible that that occurs if that factor is because of a round off of more than a factor of 2, namely. Okay, I'm not even understanding what I'm saying now. Yeah, we were aiming for 10, so if we then end up with less than 5, then we must have rounded down. Okay, yeah, no, this is confusing. But yeah, okay, I'm not trying to write a branchless function, so I might as well just test it. Can I calculate the actual m value? So we can start with this nice ideal D. and then just check if that is the correct value, or that we have to take, you know, the next smaller one, which you can only do if you can calculate m. But that was pretty easy, I think. And calculate m. That was just this. So while this brute force D runs over many values of D-ish, I think it's possible to do it without a loop. But I'm gonna need my nice delta function, which I wrote here. And this is S. Well, it's not really S, but it's derived from S, and then this turns it into S. Should probably not use K here. So K, L, M, N, O, P, Q, R, T, T. It's actually also not, I don't think it's S either. Anyway, this returns the nice delta value. Let's call this on the ideal delta. Yeah, that's nonsense, because this m value should be an integer, like pretty close to an integer now. Where is my m? Yeah, so I can calculate m. Though I should be able to use just an int here. Okay, I'll use calculate m for now. Min, max, and it returns it passes a d as d. Yeah, no, that I don't want that. So let's write a new one. Let's call this one brute force. it's a part of the BF suit, as it were. And then the conclusion here was that this will be between 4 and 10. So 4 is less than m, and m is less than or equal 10. And then if m is less than 5, which means it is equal to 4, now we probably have to multiply this exactly by 2.5, I bet. Yeah, that looks confusing now. Yeah, to be faster as well. Let's see if this works. Already had a nice delta. Yeah, that's what I copied it from. Looks exactly the same. Yeah. Oh, okay. Let's not put it here then. Instant core dump. One. Infinite. Okay. Is it like the very first one or something? Oh, my nice function doesn't work. Hmm. Folders had a breakpoint there in nice delta. No? 178. Before we calculated. It's strange, shouldn't it be 10 to the power minus 7? Because it's a tiny little bit larger. Okay. Oh, k is 0. Why is k 0? Yeah, but this should never happen. See, that's why. There should have been more than this. Because it should have rounded up. And if it rounds it up, it's larger than this, so this can never become 0. So this has a horrible running off error now. Okay, get it. First of all, my M here is K2 minus K1. Pretty sure of that. Yeah, it totally is, because so we divide this range, this distance, by delta, so you get the number of deltas. So in this case, you could get 1, 2, 3, 4, but we should return 5. And that is, of course, the K2 minus K1. So this is 0, and if K2 was here, we have 1, and so on. So K2 is K1 plus 4. Difference is 4. We should return 5 because we want to return the number of carrots. Especially in a case like this, say, where we start at a min. K1, K2 is 1, 2, well, K2 minus K1 is 1, 2, 3, 4. And we have 5 carrots. Thus, this should return one more than the M. But then why is this called calculate M? Oh shit, calculate M does already add 1. Man, the floating point round-off errors are killing me. Well, that brought us past the first one and several more. Yeah, that's true. This is an illegal value of D. How did it get that value? Yeah, that is ridiculous values. Yeah, I think that this factor now causes it to round it up even so much that we can get a value of 10 here. This 10 should also never happen. It's nonsense. So case 10, it should not be larger than 9. Therefore, this should be 0, 1, 0 or 1. Now for 10, we get even 2. So then it's 2 times 3 is 6 plus 2 is 8. And this was 10, so we get, we divide by 8, which is ridiculous. It should divide by 1, 2 or 5, not by 8. Night delta sucks in many ways. Yep, okay. That is 11, isn't it? Yes. Ignoring the loads of 9s, this is that exactly power of 10. 10 to the power minus 6. And this is exactly 2 times 10 to the power 6. Therefore, 10 to the power minus 7, aka the nice ideal D, times 10 is exactly equal to min. And 20 times that is exactly equal to max. Which means K2 minus K1 plus 1 is 11. It can just happen. But. Okay, is it 11? Should be maximum 10. What? Yeah, okay, wait a minute. Oh, right, yeah, Okay, so... if it exactly fits, which is ridiculous, but that happens in this case, then it would be 11, which we don't want. I want to have something less than 10, as long as that is larger than 5. So my D should be incremented by, well, since it is power 2, to be incremented by a factor of 2. And then we get 5 times D is equal to min. And 10 times D is equal to max. With a difference of 5 plus 1 is 6. Which of course falls in this range. I think that because I need to use 9 here. So then what do we get? Yeah, well, no way. No way, 1. Holy small. That is does that still fit in an int? Nope. Okay, so the problem is here. It should still be int internally. Yeah, I might as well return it then. And which makes it equal to the other one. Yeah. Oh, that, yeah, that's just arg. That was another difference. This one takes class D. En it was finally successful. No, it wasn't, because everything it prints is different. It's a lot different. So these kind of values are, of course, unacceptable. Can't we store 0.05? Of course you can store that. Printing stuff with too much precision, oh maybe. I think I want to have one, maybe even 2 digits less precision. You will still have those round off errors, but I just don't want to see it. Come on, just don't want to see it. Just confusing. Yeah, this is also unacceptable. It's unacceptable that M is so small. Must be at least 5. M is 1. M is 2. Ridiculous. It is not working at all. God, it's 22. Quite fast. M is 1. Mm-hmm. That is correct. One. Okay, okay. Hmm. Yeah, okay, I should return 4, right? Hmm. Oh, we got this one. And with less than 5. This is not good. I should not multiply it by 2.5. Interesting. I thought that had to be the case, but apparently it's not. Why? Image less than 5. I don't get it. We should try to get in the neighborhood of 10. So how the hell do I end up with 4? That's... maybe I should stop because I don't see it anymore. continue tomorrow, I guess. My back is hurting. I think that no, okay, let's try it with these min and max values and then try to think about it. Min and max. I'm going to use ChatGPT as a rubber duck. So we have and then go to a new chat. I don't want it to know that I'm totally ignoring the code that it wrote. I'm trying to solve the following problem. Let me copy that from the description of this video. Okay, so I wrote this function, but it fails for the following input. The correct D is most likely yeah, I'm gonna go for the brute force value, I think. Do I already have that calculated? I think it is, because we're calculating that on line 251. Yeah, calculated here, and then afterwards I'm calculating my own value, and now we are inside this function, I think. So this is already calculated. aka S is 2 and N is -5. You can check this. Or then the expected K1 value would be this value divided by this value. So that's 1, right? I mean, I have to round it up. And check this. I can check this. In this case, but in that case, K1 is 1, because if K1 is 0, we have K1 times D is 0, and 0 is less than min. While if K1 is 1, we have K1 times D is 2e minus 5 is greater or equal min, which is equal to this. This is 1/millionth, 1e minus 6, which is smaller than 2 to the power 2 times 10 to the power minus 5. So with K1 is 1 times D, and D was guessed to be 2 times e to the minus 5. So yeah, K1 is 1. Furthermore, K2 is no, K2 should be the floor of max divided by D. So that is 10. K2 is 10. Because then K2 times D is, I can do that for my head since this is 10, is, well, D was this, so that is 2e minus 4, 10 times that, which would be less than max. And max is 2.1 times E4. It's 2.11 E minus 4. Yeah, so that is less. Therefore also less than or equal. While if K2 would be 11, we would have 2 times d is 11 times 2e minus 5 is 2.2 e minus 4. Which is larger than max. Thus, m is k2 minus k1 plus 1 is 10 minus 1 plus 1 is 10, which is less than or equal 10, and therefore allowed. Also, smaller, okay. Also a smaller value of the would lead to an m larger than 10. Trivially so. So the brute force version is correct. Okay, so this verifies that the correct values are t is 2e minus 5 and m is 10. And I don't even get close to that. Why? The brute force version found it. So m is 4 and then no next. And another next on writing to m out. And now m is 1. How? Yeah, it doesn't make much sense now, does it? The ideal D is 2.1, but the real one is 2 to answer eventually. That is a round down. This is rounding up. This is gonna round it up to 5 times 10 to the power minus 5. Min is k1 times ideal d. And max is k2 times ideal d. And thus m is 2 minus k1 plus 1 is min divided by ideal d. That's k1 minus max divided by ideal d plus 1 is min minus max divided by ideal d plus 1 is 10 plus 1 is 11. This is larger than the allowed 10, but it is very unlikely that both min and max yeah, I'm using it as a Robert Duck GPT. And S is YouTube. It's also by Robert Duck. I can't have enough Robert Ducks. This is larger than the allowed 10, but it is very unlikely that both min and max are a precise multiple of any d. So that very likely m will end up as 10 instead. The function continues. Yeah, and I think here's the problem, because this rounds monstrously up, going from 2.1 to 5, which is not necessary, because 2.1 would lead to 11, so, and 2 would lead to 10, which is still allowed. So we don't have to round up necessarily. It's a bit confusing though. I think some trial and error just has to happen. So this gets us close, and I probably should not calculate a double, not a nice ideal double, but more the S and N core values as integers. Do you write continuous like this or not? Is it more like continuous? No, Underline. Red wiggly line. Ugh. The red wiggly line. My next horror movie. And it's not what I want. I think it's continuous. Like that. Ah, that looks better. AI will never correct you. You know, if you type something completely wrong and it understands what you mean, it's not going to. By the way, you typed this, but you probably meant that. No, it doesn't say that. And it still looks weird. How do I write that? Continues. The third person single person of to continue, meaning keep doing something. No, I think it's actually good. Double nice ideal D. Yeah. No. Let's just find let's find the S and the N that belongs to this value. $183. Why is it so difficult? Let me drink some water. I'm gonna create a D. Then this is actually, oh no, then this should return D. D, okay, I can pass D like that. I'm really going to do this. Let's just use class D. Is that called a lower bound? Might as well make it 10 or larger and then test one value lower, or it's not absolutely necessary. Yeah, okay, I'll ask something. Can you make a suggestion for noise delta? It's probably going to introduce 5 loops again, but well. Yeah, and let me think about instead. This stuff. So if this is the range, then the ideal delta divides it exactly in 10 pieces. So we would have this. Maybe I'll really just make it 10 here in my example. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops. One, two, three. Not fast enough. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. I'm just leaving out the power of 10. So the number of ASCII stuff I used must be divisible by 2.5, which means divisible by 5, right? And then times 2. And we have now a length of 1, 2, 3, 4, 5, 6, 7. Brilliant. Let's make that 10 then. We're gonna make it 5 actually. That's gonna work. 1, 2, 3, 4, 5. So divide by 2.5 would be 2. Nah. Cannot even put an ID in it then. Let's make it 10 then. So more like this. This is 10. Yeah, what? 10. I can't count. 1, 2, 3, 4, 1, 2, 3. Well, okay. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you're shrinking it doesn't make sense, you would think, because then then M would become 22, which is not done. But MS12 is possible, so a little shrinkage is possible. In which case I would have to show a shrinkage of... Does 12 need to fit exactly? I don't even know, man. It's too difficult. Maybe a numerical examples here would be better, but those are also hard to think of. Well, what it can do is it can shrink continuously, because this is just a floated distance. So I can show the 2.5 things and then say, okay, then its M is that. Therefore, M can be in that whole range somewhere. That is still progress, but it's not forced. So it could be... well, it could be... It could have to shrink. To be an allowed distance. 2. And now we want to divide this by 2.5. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 characters. That means 10 divided by 2.5. That's 4, right? 1, 2, 3, 4. I can just squeeze an ID in here. That then, can that still fit? Theoretically, it cannot fit, right? I mean, divided by 2.5, that means that it's halfway, halfway one of the segments. As is shown here as well. This was an integer number. Yeah, it cannot be a whole number. So that looks correct then, and then we have in total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. In this case. So then we get this times 2.5. Oh, 2.5. That's gonna work. 10 can be divided by 2. That means that 1, 2, 3, 4, 5. This is halfway. That's where it ends up. And then this is something like, well, a lot of dashes, more or less in the middle. More or less. What? Don't tell me it cannot be smaller than 5. Oh, wait, I can shift it a little bit. So now I'm counting this one. But you've shifted a little bit to the left, then we have only 1, 2, 3, 4 left. That's pretty much an edge case, isn't it? This is no longer the ideal D. Substitute ID with minus T. Nor is this. Okay, so it is not sufficient. Actually, it is sufficient. It must be larger, greater or equal than 5. And then possibly that is, no. Yeah, it must be greater or equal 5, and possibly if and only if it is 5, we might be able to make it 10 if the simply by trying a d that is half the size, which is of course only possible if d is not 5 already, because you can't use 2.5. But we could change d from 1 to 5 or from 2 to 1, adjusting the power of 10 in the first case, of course. Yeah, it is still very, very, very difficult, man. Because this picture it can only reach if, let's 28 is even easier, I think. So this picture you can only reach from by rounding down the ideal d, getting m is 28, if the rounding down requires a factor of 2.5, which means that this d begins with the digit 2. And that means that this one was, the ID is 4.999. And then we had to go down to 2, which is an almost a factor of 2.5. And then you can get all the way up till 28. But that then also means that, because 28 is way too big, of course, that the next one is, make it larger, so you have to go from 2 to 5. The next one is simply this one then. But then possibly no longer aligned. But I definitely want to see if it is not aligned, we get 10, yeah. And if it is aligned on one side, no, man, that's not true. If it is aligned on both sides, which is very small chance, we would have MS11. In that case, you have to increase it again, which would then be a factor of 2. So then we would get 5. And if it is not aligned, then you'll just get MS10, and that then will be okay. I must be just really stupid today. Just can't wrap my head around this. The feeling that this must be super easy, so super simple. If just you would understand what it really is about. I'm gonna read what the AI said, just, in the hopes. This is not possible. So it's already nonsense after the first sentence. Well, let's try to read it anyway. Well, not always possible. In most cases it is possible, but sometimes it's not possible. It can only be between 5 and 12. That's the only thing you can guarantee. Arduino. En here it's SCSS. Let's switch randomly between languages. Shouldn't it be greater than or less than and not equal? Ceiling of x cannot be equal to x plus 1. I can't follow this. Yeah, I disagree. And that sucks because it's rather at the top. And then I have to ignore everything else. And then try to start a discussion about the top. Okay, anyway, let's do that. I lost you at the top. The floor of x is larger than x minus 1, not greater or equal. Prove me wrong with a numerical example. Likewise, not less or equal. I didn't get how you got from there to but I think the correct equation is damn it. If it fits exactly, it is 1 more than RS divided by D. So yeah, plus 1 and then equals, or less of course. And if it doesn't fit exactly, it's 1 less than that, which is RS divided by D. And then, yeah, we can lose another one. It's actually true. Yeah, we can lose another one. Is it? So, shift it like that. It's a little bit larger. But that's the whole point, of course. Oh, this has to do with alignment. Yeah, but RS divided by D. Oh, it doesn't have to fit a whole number of times, so in that case it can't fit a whole number of times. Mm. Yeah, there's just no way. No way it can be RS divided by D minus 1. It's just not possible. But. The thing is, of course, that the way we divide it by 10, so D is 10, or sorry, D is 1/10 of the range. In this case, that fits exactly 1 to 10 segments. And then the begin and the end is exactly on the end of the range. Therefore, we have one more. Now, if you would make the segment a little bit larger and don't align on either side, then both K1 and K2 fall off. So it's really, really close to MS9, which would be the -1. But then I would be dividing this range by something that is a tiny little bit, at least a tiny little bit larger than 10 or a tenth, let's say. That's where it was. So ID is RS divided by 10 and then a little bit larger. Thus, more like divided by 9.99. Did I say that correctly? So you have, say, RS divided by RS divided by 9.99. And then aligned such that both endpoints fall off. Then I get the floor of 9.99. Floor's the maximum. That's nonsense. Shit, I don't get it. Okay, the smallest value minus the largest value, plus 1, is less than, because both are not included in the range. M is less than or equal the largest value minus the smallest value, plus 1. And that can be equal because both are included in the range here. Therefore, you can write this as max minus min, which is RS, divided by D. Then we have this part and this part. Minus 1 plus 1 is minus 1. Okay, so there is a minus 1. Is less than M, is less than or equal RS divided by D plus 1. Therefore, to guarantee M is less than 10, less than or equal 10, for any alignment, you need D is greater or equal RS divided by 11. And to guarantee M is greater or equal 5, you need D is less than or equal RS minus 6. So the safe interval for D is between RS divided by 11 and RS divided by 6. So I'm saying sometimes that is not possible, which means I suppose there wouldn't be an integer value for this. Oh no, wait a minute. That D would not be, D is not 1, 2 or 5 times the power of 10 in that range. Because you picked ideal D is RS divided by 10, you can express these bounds from ideal D alone. Lower is 10 divided by 11 times ideal D. guarantees m is less than 10, and upper is 10 divided by 6 times ideal d, guarantees m is greater or equal 5. Now choose the largest noise value that lies in lower upper. If none lies inside, so we choose the smallest noise, larger than lower. No, that's a wrong thing to do. Okay, so for certain ranges, there is no noise value for D such that you must guarantee that at all times m is greater or equal 5, even if that means that m is greater or equal 10. Sorry, greater than 10. So your remark if none lies inside, small is not, is oh, has it wrong or something? That should be if none lies inside, choose the I would say the I don't get this at all. Okay, that's the largest noise less than lower. To keep noise is less than upper. Well, equal was allowed, right? Our upper is equal. Yeah. No. This is about the noise value now. Upper the highest value of d, that is the upper. That means the lower value of this is not equal. It must be less than, I think. Keep nice less than upper, so that m is greater or equal 5 is guaranteed. Which means that, well, it has an equal size here. Wait a minute. For certain ranges, there's no nice value that. Well, now I'm copying what the AI said. How did we get to the 11 and the 6 from here? I have to do that. Repeat that as well. So the guarantee m is less than or equal 10. You need d greater or equal rs divided by 11. Huh? Now this thing really keeps me thinking at the moment. I'm no longer convinced immediately that it is wrong either. That would be pretty impressive if this is correct, because it's like I'm like, huh? And then if it is correct, wow. I think this is kind of a guarantee, right? If you pick a certain rs divided by d, then m will be between these things. So if we want to assure that m is never larger than 10, then this must be less than or equal 10. Yeah, of course. Okay, let me repeat that. Next, we get to guarantee 5 is less than or equal, m is less than or equal 10. We need that 5 is less than or equal that thing is less than or equal 10, because this is larger. It won't even be equal to 5, which is ridiculous, because sometimes it will be equal to 5, and that's okay. Tillman, nothing. I don't get anything. I think I can put a 4 here. Let's put a 4 here. Well, actually, now I made it smaller. Why? I want m to be at least 5. And m is an integer. So, since it is larger than this must be greater or equal 4. Yeah. So because m is an integer and guarantees 5. Oops. 5 is less than or equal m. Oops. From that I get 5 is less than or equal rs divided by d, and rs divided by d is less than or equal 9. Yes. Subtract 1 from both sides, and here add 1 to both sides. Or now we have to invert it, so we get 1/5 and then divide it, multiply it with rs. But if you do 1 divided by, then these things change. So you get rs divided by 5 is greater or equal d is greater or equal rs divided by 9. To invert and multiply by rs. AKA rs divided by 9 is less than or equal d is less than or equal rs divided by 5. And that is quite different from what you got. Yeah, who is right? Okay, so in order to guarantee that m is greater or equal 5, okay, this one, we must guarantee that this holds. At all times. So plus 1 is 5 must be less than that. So 1/5 must be greater or equal d divided by rs. So rs divided by 5 must be greater or equal d. So d must be less than or equal rs divided by 5. That one, which is the upper bound. It seems that we must decrement d then. I could just start with rs divided by 5. And then round d down to the nearest nice value. It doesn't even matter if it fits in. Something is wrong here. I want it to be. Well, okay. I start with this, round it down to the nearest nice value. And then we try even a smaller nice value. And if that smaller value is still greater or equal rs divided by 9, then we pick that one. While if the first value is already less than rs divided by 9, then we pick it anyway, because we must do this. The correct algorithm therefore seems to be 1. Calculate rs divided by 5. 2. Take the nice floor. To the nearest less or equal nice value. 3. Try if the next lower value, a lower nice value, still results in and if so, pick that one. Otherwise, use the value from 2. Eh? So it agrees with me up till here. And then suddenly everything becomes equal signs again. No, why? I could have laying in bed. There's a mysterious 9 turns into a 10 here as well. Or, oh, wait a minute, this is about M. Excuse me. No, I understand this one, yeah. The guarantee M must be greater or equal to 5 and less than equal to 10. Okay, that was our premise. How do you say that? And that then would be implied by this. Yeah, I just copied my formula now. It did not say that it guarantees with it though. I use RS divided by 9 less than or equal to less than or equal RS divided by 5. So it uses that too. Okay, never mind then, but I must say the 5 is a bit scary. Because, yeah, that does hang on the fact that we remove the equal sign here, which is, of course, incredibly close to being less than one floating point round off error away. So what does that mean? We allow D to get as close to RS divided by 5 as being equal even, then the guarantee is that this is 5 minus 1 is 4. Then we have the guarantee that 4 is less than M. So then M is almost 4, basically. It only is 5 because it can't be 4.00001. It feels wrong. I have to agree. It does feel wrong. But yeah. Without any floating point round off errors, it is correct. So the mathematics are correct, it seems. Is it also correct if, say, if this is not an integer? Especially then. For example, if RS is 5.5, that makes a big difference by dividing it by 5 or 6. 5.5 divided by 5 is a little bit more than 1, while divided by 6 is a little bit less than 1. And D is therefore then, well, it has to be a nice value, so it can't be, in one case it can be 1, and if this is say 1.1 or 0.9, then if this is 1.1, which it would be if we divide by 5, then it can be 1, while if we divide by 6 it would be forced to go to a half, because D must be 1, 2 or 5 times the power of 10. So if RS is say 5.5, then D can be 1 instead of a half, which would make the difference as 5.5 divided by 1 is 4.5. And then, yeah, M is guaranteed to be larger than 4.5, which is totally cool. Or if we divide by 6, D would really have to be put at a half, and then you get 5.5 divided by a half is 11 minus 1 is 10, and then M must be larger than 10. Well, in that particular case, maybe it could become 10, but yeah, on the other hand, it's just a guarantee, right? I don't know. It is all ungraspable. Given you a requirement, use the largest D with M greater or equal 5, unless a smaller D gives M equals 10. A robust algorithm is set D0 is a nice floor. Let's do it. A nice floor of RS divided by 5. Is that my algorithm? It's like copied it again. Yeah, RS divided by 5 takes a nice floor. This guarantees M is greater or equal 5 in the worst case. Because D is now less, so M becomes only larger. And this was already on the edge. If M min max D0 equals 10, return D0. Otherwise, step down through smaller noise values. Turn the first with M is 10. If none yields M is 10 above, yeah, well, nah, I like my algorithm better. Yeah, I think we do need an operator less than. Let's see if we did that correctly. If S is 5, make it 2. If S is 2, make it 1. Otherwise, make S 5 and decrement N. That looks good. Yeah. Yeah, I think I need this one. That actually got my style correct. It's amazing. Shocking. Well, almost. There was a space here. But I never talked about that. The noise floor and tick counter. This is a bit scary, I must say. So every time I start a new chat, in order not to step on ChatGPT's toes, if I ignore something it said, for example. But then it turns out that it does know what we were talking about. It doesn't matter that I start a new chat. It remembers it all these days. I didn't talk about tick marks or anything. And it fucking understands that this is to calculate the tick count. So it totally remembers the previous conversations. Otherwise, we would never call this tick count. Well. Sometimes I do have the feeling that ChatGPT thinks, you're being such a smart ass, I don't have to explain anything anymore. This is a really big jump here. Or jump, yeah, well, at least it leaves it to me to do all these calculations and verify it completely. It is even too lazy to fill in min and max. Again, I mean, I can't even remember what that was. Would have to scroll up. I still think this is funny. Count, yeah. That's a really nice short function if this works. See how that works. So this doesn't work because the integer gets out of range for certain values. But yeah. I made that mistake as well. Nice floor. Yeah. Well. Yeah. Okay. Try this out. Just dump it in somewhere. Hmm. Holy... Oh, wait a minute. No, never mind. I thought it finished successfully. Every print is an error. It's not that bad though. Oh, these are bad. It returns 5 when it could have been 10. Three, 5, 8, 1. REX. Oh yeah. Let's use something with integer values. This one. BF stands for boyfriend. I mean, brute force. Oh, imagine that it makes no difference. I'm just kidding. Which is supposedly always right. But we can verify. Minus 2, max is 50. With a D of 5. K1 is 1. And K2 is 10. Is that correct? So D stands for delta, K is multiplied with D, and K times D must fall in the range. So K1 times 5 is 5, which falls in this range, while K1, well, 0 would not fall in the range. Likewise, the largest value that you can multiply, the largest integer value that you can multiply 5 with, such that it falls still in this range, is obviously 50, so 10. From it follows that m is 10 minus 1 plus 1 is 10. Check. Well, your code returned D is 10. Which belongs to K1 is 1 and K2 is 5 with M is 5. But we prefer 10 if possible. I can of course implement my own algorithm. Let's do that, because I think my algorithm was better anyway. I said calculate RS divided by 5, take the next floor to the nearest less or equal nice value. I think the function works. Oh shit, that was not what I wanted to click on. That was a message from Reddit. What kind of picture was that? Now I want to see it. Reopen, close, stop. No. This one, KDE something. Yeah, I'll grab image 5. No. So yeah, I think we should do yeah, calculate RS, calculate upper. Well, I'm probably going to need lower as well. Calculate that. Okay, we need all of them. And then do that one. And then what I did say is try if the next low noise value still results in that. If so, pick that one, otherwise return the value from 2. So we do need a tick count, but only after we calculated everything, right? Do we need tick count now? No, I don't need a tick count now. So in the end, we calculated D. Before I return that, I also want to set M as output variable. But more importantly, we calculate D2 as the noise floor of a lower decremental. Make a copy. D2 is D and then decrement D2. Try the next lower noise value, but it still results in RS divided by 9 less equal than noise D. Well, if that is the case, then we pick that one. In other words, if that is the case, then D becomes D2. And that being the case was this, where noise D2, that is noise D2. RS divided by 9 is lower. So if D2 is still greater or equal lower, then use that one. This is the algorithm that I had. I don't have a loop. This sucker keeps adding loops to my algorithms. Well, not necessary, hopefully. I would cross my fingers, but I can't type if I cross my fingers. I also can't code. Expected something before something. How about that one? Pointing, things go deep, and you get a lot of errors still. Shit. Okay, the example that I was using. RS252. Still failure. Oh. Well, that's not my code then. The difference, RS is 52 minus 2 is 50. And then we oh, wait a minute. I divided by 9, not 10. Okay, so we divided by 9? Divided by 5, I think. What the hell do we start with? Yeah, divided by 5, okay. So 50 divided by 5 is 10. And then D is 10, for obvious reasons. I mean, that's an allowed value. So nicify 10 becomes 10. And then, yeah, M is 5. But we should try one smaller, because that results in 10. Now, if I decrement D, then I should get 5. And then we should divide RS divided by that. No, we shouldn't. Oh, I divided by 9, and then it doesn't fit. Oh, wait, what? That's the wrong way to verify it then. Yeah, I need to calculate M simply, and then test if M is less or equal 10. The test is wrong. Okay, my algorithm did not work either. So we decrement D, and then we calculate the tick count of that, not this test. If the tick count of D2 is less than or equal 10, probably equal to 10, by the way, then we use D. And then I don't have to do this. The nonsense. Well, here, that's better. Let's try this one. Not an empty file. $252 is gone. That's something. Okay, let's give ChatGPT a chance. Yeah, that's what I just discovered as well. The simplest way to make this bulletproof and fix your 252 counterexample. Enumerate a small local set of nice candidates. Nah. Yeah, it really like loops, and of course we would never ever notice it because it's fast enough. But come on, you don't need a loop. You don't need any loop. I don't have a loop. My code doesn't work, but I don't believe. I don't believe we need a loop. Shall I test this anyway? I'll test it anyway. But that is nonsense. Maybe I calculate M separately afterwards. I don't think it even calculates here. Zero. Oh, it's called stick count here. Deep inside the guts. It gets too complicated. So we call nice delta. And then having the delta, we can calculate, we can do the tick count. Calculate tick count afterwards, why not? Shouldn't make that much difference. Oh, nice floors not used. How is that even possible? That was just a warning? Yep. Okay, let's run this. Nope. Billions of errors still. Yeah, I'm going to bed. Hopefully I'll get this to work tomorrow, because it's ridiculous if this takes a long time. Just a single bloody function that I need. Yeah, this is correct. Ridiculous large function. Yay, that worked. Nah. couple of single steps. No, just one is enough. You only need step once in either case. But yeah, I've got that one. Although I think it's only possible to end up equal to 5 if 10 is also possible. So you could do this, and then if it's 10 you're done. But to be honest, if it is larger than 5 you're done. Only if it's equal than 5 you have to try the larger value and see if that is still less than or equal 10. And if it is less than 5, you always have to increment. Don't even have to check if it is still less than 10 in that case. So we do this and then get the M value. So I already did that, but maybe not just quite exactly like I just said it. Errors divided by 9. It should have been 5, no? The smaller d, the larger m. But maybe that was my mistake here. I should have used the 9 one. So we'll use this one, and then let's just immediately calculate m. And then decrement d. I think the only way to verify that is to calculate that again. So I have to int m2 is calculated for m2. Unless, so here, if m is larger than 5, we are done. Return d. Nothing. Hmm. I don't know. Just don't crash. Okay, this far. Okay.